Hello ladies, it's Mr. O'Sullivan. Today we're going to be looking at how to set up the mid-segment of a triangle. So today's learning target is I can set up the equation by using the mid-segment of a triangle. So before we even begin, here's a few definitions. The mid-segment of a triangle, also called its midline, is a segment joining the midpoints of two sides of a triangle. This is actually going to be very helpful for us when we go over proportions in our triangles, which will be in our next unit or in 2 units, I forget. But where we look at proportions and we look at the relationships that are taking place between our side lengths and our angles. The mid-segment theorem states that the mid-segment of a triangle, which joins the midpoints of two sides of a triangle, is parallel to the third side of the triangle and half the length of the third side. So if I look, DE is a mid-segment or a midline. So if I look at DE, it's right down the middle of my triangle. And it's basically creating some relationships. It's saying that I have segments that are congruent to each other. D is the midpoint of AC, so I can say AD and DC are congruent. I can also say E is the midpoint of CB, which says that EC and EB are congruent as well. So I can actually use this to find a lot of beneficial information. And I also know that DE and AB are parallel. So here's how it works. If you notice, to get from 8 to 16, I have to multiply it by 2. So I can say 2 times 8 equals 16, or you know that I can say 8 is equal to 1/2 of 16. These are both acceptable ways on how to set up your midline equation, which we're going to be doing shortly. So if you look here, I have it written as DE is 1/2 of AB. However, I know a lot of us don't like to work with fractions. I also don't like to work with 1/2 unless it's nice even numbers. If it's odd numbers, it's a little annoying because then you have decimals. So another way you can write this is 2 times DE is equal to AB, because if you want, you could multiply. I'll rewrite this equation. So if we know that DE equals 1/2 AB, and we want to get rid of this divide by 2, we're going to multiply both sides of our equation by 2. So my 2's cancel. So I get 2DE is equal to AB. So I can say 2 times my midline is equal to my base. So just like here, 2 times 8 is equal to 16. That's the way I would recommend it. It just makes a lot of sense, and you don't have to really deal with a fraction. So for each of the following, write out the mid-segment theorem using side length. So we're basically just going to set up our equations. So I'm going to do the first one, and then you're going to do the next 2. So if I look here, my midline is RS and my base is DF. So I know that 2 times RS is equal to DF. And that's my final answer. If I look at this example, my midline is RT and my base is FE. So if I want, I would have to double RT and set it equal to EF. And that would be my final answer. Try to do the next one by yourself. If you do the next one by yourself, you would be doubling your midline of ST and be getting 2 times ST is equal to ED or DE. It doesn't matter what your ordering is. So that's how you use the midline or mid-segment to assist you with these problems. What we're going to be doing is we're going to be doing the exact same thing, setting up our equations. That's it, nothing else. So set up the mid-segment theorem for each of the following images. Do not solve. We are not solving. We are just setting up. So if I look at this example, my midline is x minus 4, and my base is 20. So I know that I can do 2 times x minus 4 equals 20. And that's my final answer. If you want, you can distribute and simplify. I can distribute and get 2 times x is 2x. 2 times minus 4 is a minus 8, and that's equal to 20. That is also acceptable. If you want to distribute, go ahead and distribute. Just make sure it's correct. In this example, I have my midline as x and my base is 28. So I take that x, multiply it by 2, and set it equal to 28. So I get 2x equals 28 as my final answer. Let's look at the next one. My midline or my mid-segment's x. My base is x plus 9. So I just do 2 times x equals x plus 9. That's your final answer. Our next example. My midline is 2x plus 16. My base is x plus 14. I double that midline and set it equal to my base. You can leave it like this for today, or if you want, you can distribute and simplify. So let's distribute and simplify just so we can practice. Distribute my 2 to my 2x and my 2 to my 16. 2 times 2x is 4x. 2 times 16 is 32. And that's equal to x plus 14. Also an acceptable final answer. Number 5. I'm going to do 2 times 10x minus 21 equals 2x. That's my final answer. So, did Mr. O'Sullivan do anything incorrect with this example? Yes, he did do something incorrect. He doubled his base. He is supposed to double his midline. So when we do this example, what we should really be doing is 2 times 2x equals 10x minus 21. That is your final answer. If you want, you can simplify. 2 times 2x is 4x. So I get 4x equals 10x minus 21. And then in our final example, I have a midline of 3x and a base of 4x plus 20. So I double my midline, which is a 3x, and set it equal to 4x plus 20. Again, you can leave it like this for today, or you can simplify. 2 times 3x is 6x. And that's it for today. So ladies, what we did today was we just set up our equations. We did not do any solving. We just did setup. If you have any questions, email myself or Miss Colorundo. There is no Delta Math. It is just an edpuzzle today. Have a great day, ladies.